In this video, I'm working through number 5 in the 2019 AP Calculus test, form BC. In this question, we're not allowed any calculators. We've got consider the family of functions f of x equals 1 over x squared minus 2x plus k, where k is a constant. Part A, we're supposed to find the value of k for k greater than 0, such that the slope of the line tangent to the graph at f at x equals 0 equals 6. And so remember, the tangent line is the first derivative. So in A, we're going to have to apply the quotient rule for derivatives. So we're going to view f of x as a quotient of two functions. I'm going to call it h of x over g of x. Where h of x is equal to 1 and g of x is equal to the denominator there. So we'll say that the derivative of this quotient of functions is equal to, you guys should remember the quotient rule, h prime of x times g of x. So the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator. And that's all over the denominator squared. So this is equal to, taking the derivative of the numerator, we get 0. 0 times anything is 0, so you can skip that part, and then we're going to go straight to the derivative of the denominator. Using the power rule, we'll take this 2 down before the x, get rid of k, get rid of this x. We've got negative 2x minus 2 up top, and then on the bottom we've just got the denominator squared. So x squared minus 2x plus k, quantity squared. And so we're going to evaluate that at f of 0. So we've got f primed of 0. Remember, f of x is equal to h of x over g of x, so this is actually the derivative. This one here is f primed of x. So f primed of 0, just plug in 0 for the x values there. We've got negative 2 times 0 minus 2, and that's all over 0 squared minus 2 times 0 plus k, quantity squared. Get rid of our 0 terms here. So we've got negative 2, which is equal to 2, and that's all over. We've got no terms left but k. We'll square that. So k squared, 2 over k squared, we saw that in part A that equals 6. So we'll say this equals 6, and so we'll just do some simple algebra here. Multiply both sides by k squared, so we've got 6k squared is equal to 2, then we'll divide by our coefficient. We get k squared is equal to 2 over 6, or 1 over 3. Then we'll take the square root of both sides, and we get k is equal to 1 over root 3. Remember, the square root of 1 is just 1. And we can rationalize the denominator if we want to by multiplying by root 3 over root 3, or simply multiplying by 1. And we get k is equal to root 3 over 3. Or you could leave it as 1 over root 3. Either way is fine. Moving along to B. So we've got for k equals negative 8, find the value of the integral from 0 to 1 of f of x dx. This is just a simple integral. So we get the integral from 0 to 1 of 1 over, we're going to plug in this value for k. So we've got x squared minus 2x plus a negative 8 or minus 8. And then we can factor this out. So we get 1 over x minus 4 times x plus 2. And we can check that if you want to. X squared plus 2x minus 4x minus 8. That's correct. And so what we can do here is partial fraction decomposition. So we have this factored quadratic equation down on the bottom. We're going to say this function here is equal to a over x minus 4, the first part, and we're going to add to that b over x plus 2. Again, partial fraction decomposition. And so now we need to solve for a and b. All right, so that equals 1. We're going to multiply by our denominators. So we're going to get 1 is equal to a times x plus 2. And we're going to add to that b times x minus 4. Sorry, gotta have the denominator, x minus 4 times x plus 2. And when we multiply by these two denominators, this one disappears. So we get left with 1 on that side. And so let's look at our roots here. If x plus 2 is equal to 0, then x is equal to negative 2. We're going to call negative 2 our first root. And so let's solve using our first root of negative 2. So 1 is equal to a times negative 2 plus 2. That's going to cancel out, and we're going to add to that b plus negative 2 minus 4. And so we get 0 here. Our a term disappears, and we get 1 is equal to negative 6b, or b is equal to negative 1/6. And then let's use our second root. If x minus 4 equals 0, that means our root is 4. So let's plug in 4 for our second root. We can find a there. So a is equal to 4 plus 2. Sorry, a times 4 plus 2 plus b. And we're going to get a 4 minus 4, or 0 here. So we get rid of that term. And so we got 1 is equal to 6a, or a is equal to 1 over 6. Now we can go back and do our integral. So we did our partial fraction decomposition, and so what we can do is take this function using our values for a and b and do the integral using this function instead of the original. And so we're going to have the integral of a over x minus 4 plus the integral of b over x plus 2 from 0 to 1. And so we'll get 1 over 6 over x minus 4 dx. I'm going to add to that the integral of the other part. We get a negative 1 over 6 over x plus 2 dx. And so we can just take the natural log of both sides and we can find the integral there. So we've got 1/6 log absolute value, remember, of x minus 4. There's our first term. And then we're going to subtract from that because of our negative sign here. We'll subtract 1/6 times the natural log of the, remember again, the absolute value, x plus 2. And then we're going to evaluate from 0 to 1. And so evaluating our first term, we're going to plug in 1 for x, and we get 1/6. 1/6 natural log of 1 minus 4 is negative 3, but remember we had the absolute value, so we get log 3, and we're subtracting from that. Uh, 1/6. Again, natural log x plus 2, 1 plus 2 is 3, so we get ln 3. And so that's convenient, we can just get rid of that. Anything minus itself is equal to 0, logs included. And so in our second term, looking at 0 for x, we've got 1/6 again. 1/6 natural log of 0 minus 4 is negative 4, but we've got absolute value, so log 4. And we're subtracting from that 1/6. Plug in 0 for x, we get 1/6 natural log of 2. And so if you remember back to your algebra rules, we've got base, natural log, these two share the same base, and so we've got 1/6, the same coefficient here. We're just going to simplify this saying this is equal to, remember we have our negative sign here, negative 1/6 natural log of 4 divided by 2. Remember, the difference of two logs of the same base is the same as taking the quotient of those two logs. And so that is equal to negative 1/6 natural log 2. That's our answer for this part. Clean this up a little bit. I'll put all the answers up top after we're finished. Moving on to C. For k equals 1, find the value of the integral from 0 to 2 of f of x dx, or show that it diverges. Well, I mean, here's a hint, obviously. We're supposed to be looking for something. Why would they say or show that it diverges if there wasn't something tricky about this one? So let's take a look at that integral from 0 to 2. And we've got over x squared minus 2x plus 1. Well, nothing really jumps out right now, but let's take this and factor it. So we've got that same integral over the term 0 to 2, and this one factors out nicely. It is x minus 1 squared. And so here's our problem. The denominator is equal to 0 when x equals 1. X equals 1 lies between these two numbers here, so this is kind of a trick question. If we don't notice that part, then we can't figure out if it diverges. Right, so if we have 1, here's 1. We've got some kind of we've got a vertical asymptote right there at x equals 1. And so as x gets close to 1 here, our denominator becomes very, very small. And so 1 divided by a very, very small number is going to be infinity. And if x equals 0, we're going to get negative 1. And so we're just going to say it follows this basic shape there. And then, so we have our vertical asymptote here. Just on the other side of 1, something just greater than 1 minus 1 is nearly 0. 1 divided by something that's nearly 0, again, is infinity. And so I think we can see that this is going to diverge. But let's go through the math just to double check. And so we've got this integral here. Since it is an improper integral, given that there's an asymptote right square in the middle of our range, we're going to have to break it up into limits. Now this is a fairly straightforward integral. The indefinite integral of anything that follows this format of 1 over x plus a squared dx is equal to negative 1 over x plus a. In this case, a is equal to negative 1. So this is one of those integrals that's easy to memorize, like natural log for part B there. All right, so we're going to break this up into two limits. We're going to approach one from the left side, so we've got the limit as, we'll call it a, approaches 1 from the left, and then our integral here is 1 over negative 1 over x minus 1, and we'll say this is from x equals 0, that's our starting point, and we're going to x equals a, which is very, very close to 1, as close as possible, but not quite 1, because at 1 the denominator is equal to 0 and the function is undefined. And then we're going to add to that the limit as a approaches 1, or moves away from 1, on the right. And same thing here, except we're going to put x equals a on the bottom. Remember, a is almost 1, but not quite. And we've got x equals 2 on the top because that's the rightmost point that we're looking to find the integral over. And as we evaluate those, it's pretty simple. So we'll just take a, x equals a, and plug that in. We get here. And so this is equal to if x equals a, so 1 over a minus 1, negative 1 over, we're going to just work this out just like we would a normal integral. We're going to plug in this value for x, and then we're going to subtract from that this value from x. So we've got negative 1 over a minus 1, and if we plug in 0 for x, we've got 1 over 0 minus 1, or negative 1, times negative 1, which equals 1, but remember we're subtracting because it's the bottom part for the integral here, so we're subtracting from that 1, and then I suppose we should say this is a limit as a approaches 1 from the left, and this is the limit as a approaches 1 from the right. Same thing here. Plugging in 2 for x, we get 1 over 2 minus 1, which is 1. That's negative times negative 1. And then x equals a, 1 over a minus 1. We're subtracting a negative, so we'll add there a minus 1. And what does this equal? As a gets closer and closer to 1 on the left, this number is just barely less than 1, so this a minus 1 is just barely less than 0, but it is negative. It's an extremely small number. It's a negative number, and so 1 over an extremely small negative number is going to be negative infinity, but we're going to multiply that times negative 1, and so we've got infinity minus 1, and then we'll subtract from that negative 1, subtract from that 1. And from the right-hand side, a is just barely bigger than 1. Number just barely bigger than 1 minus 1 is a very, very small number. And so 1 over an extremely small number is going to be infinity. And so we can see this diverges. Diverges. It does not have a real value. Okay, so looking back up here, we could say a is 1 over root 3 or root 3 over 3. B is equal to negative 1/6 log 2, and C diverges. Simple enough.